Welcome everyone to this webinar from the Physicists Coalition for Nuclear Threat Reduction. My name is Zia Mian. I'm with the Princeton Coalition, with the Physicists Coalition for Nuclear Threat Reduction and Princeton University's program on science and global security. We're grateful to the Union of Concerned Scientists for helping us host this webinar on Golden Dome today. So by way of a brief introduction, the Physicists Coalition was founded in 2019, and it works to reduce the threats from nuclear weapons by mobilizing advocacy within the physical sciences communities in the United States and internationally. Given the civilization-ending potential of the use of nuclear weapons, we advocate for substantive changes in nuclear arsenals, force postures, and declaratory policies. We also call for fulfillment of the long-standing international obligation to achieve nuclear disarmament. The focus for our webinar today is the proposal by the United States for the Golden Dome missile defense system. In May 2025, President Trump approved the Defense Department's architecture and implementation plan for Golden Dome, which he had announced in an executive order in taking office at the beginning of 2025. This is to be a multi-layered missile defense system with ground, sea, and space-based components designed to protect the United States across its entire territory from any scale of missile attack by any country. So in our webinar today, we have three physicists who have been specializing in missile defense issues to explain why the proposed system would be technically ineffective, carry enormous projected costs, and actually make the global arms race worse in key respects. And they will also discuss some of the other implications of Golden Dome. So our speakers, in the order in which they will speak, include Professor Fred Lamb from the University of Illinois, Dr. Laura Grego from the Union of Concerned Scientists, and Dr. Igor Moric from Princeton University's program on science and global security. So just by way of a very brief introduction to the topic, since we're going to get into more substantive detail from the speakers, it's important to recognize that Golden Dome goes beyond just a missile defense system. It actually includes developing the capability to launch attacks on adversary missiles before those adversary missiles are actually launched. That means that Golden Dome carries an offensive capability as well as a missile defense capability intended to deal with missile defenses upon launch. It also talks specifically about defending American cities and not just military bases, and there's no description of how priorities will be assigned to defending cities versus military targets. And it also deals with missile defense and its relationship to US allies around the world. So it's a very large, rich, complex project. It also has a lot of technical challenges because it deals with both existing missile defense programs that the United States has, as well as plans for technologies that yet have to be developed and proven in the field. So with that, let me hand over to our first speaker, Professor Fred Lamb. So Fred, over to you.
So thank you for that very kind introduction, and I'm delighted to have the opportunity today to talk and discuss with everyone who's here this really important question. So I'd like to begin with some context, just to remind us that what we're talking about is that even a single nuclear weapon exploded over a city could immediately kill millions of people. And the panel on the right gives an example of an attack on New York City with an airburst that would likely kill over 3 million people immediately and injure almost 5 million. And of course, there would be additional fatalities by fires, fallout radiation, and so forth. Intercontinental ballistic missiles, or ICBMs, are armed with nuclear weapons. They make us vulnerable to sudden and devastating attack from far away. So a natural reaction is to attempt to intercept these missiles or their warheads to prevent their warheads from reaching their targets. During the past 70 years, the United States has spent over $400 billion on ballistic missile defenses, mostly on systems intended to intercept nuclear-armed ICBMs that might be launched against the United States. But none of these systems have proved reliable and effective in tests in defending against such an attack. We're now faced with this new idea, the Golden Dome proposal. The goal, as Zia said, is to defend the United States and its allies and armed forces against attack by ballistic missiles, hypersonic glide vehicles, cruise missiles, and drones fired against them at any time, from anywhere, by any adversary, including peer and near-peer adversaries. This goal is clearly beyond reach anytime soon. Today's webinar focuses on three aspects of defending against nuclear-armed ICBMs. First, the prospects for boost phase intercept defense, which I'll be talking about, the prospects for mid-course intercept systems, which Laura Grego will talk about, and the many costs of these kinds of systems, or even the effort to develop them. Igor will talk about that. So to give you the framework with which we'll be talking about ICBMs, let me begin by just summarizing the three phases of flight of an ICBM and the possible intercept systems that might be used to intercept during that phase. So let's go from the left to the right. This is a schematic plot of altitude vertically versus the range horizontally. In the first panel on the left there discusses the first phase, the boost phase, which lasts about 2 to at most 5 minutes. And it's during this phase that the missile is unpowered flight and its warhead is attached. When it shuts down or burns out, it has already released its warhead. The boost phase intercept, if it occurs, has to occur in this first 2 to 3, 4 minutes. Once the warhead is released, it follows a ballistic trajectory in space, where there's no air drag, toward its target. During that phase, which lasts about 20 to 30 minutes for an ICBM, the target is the warhead for the defense. The missile warhead is separated from the missile itself. We have one system designed to try to attack the warhead during this phase, the so-called ground-based mid-course defense system, or GMD system. I should also mention the Aegis BMD system, which was not designed for this purpose, but may have some capability to intercept ICBM warheads during this phase. Then the terminal phase is when the warhead descends rapidly, re-enters the atmosphere. That typically lasts only about 30 seconds. And there again, it's only the warhead that's the target for the defense. It re-enters the atmosphere, atmospheric drag increases, and then it strikes the target if it's successful. We do have another system that tries to address warheads in that phase, the Theater High Altitude Defense System, or THAAD system. Obviously, a theater area defense can only defend a very small area. I'd like to mention some of the challenges of defending against nuclear-armed ICBMs. We have repeatedly been told that this is something that can definitely be achieved historically by appealing to completely different problems and different defenses. So there was reality setting in after Star Wars about the true difficulties of creating such a defense. But then the Patriot was sent to the Gulf, was totally unable to defend even against small missiles. There's not one single documented case of an intercept and many, many documented misses. Yet it was broadcast to the public as an enormous success and breathed new life into this idea. Something similar is happening with Israel's Iron Dome. It seems that the Iron Dome was an inspiration for President to actually put together this proposal for a Golden Dome. But the Iron Dome was developed to defend against artillery and mortar shells and simple, very short range, highly inaccurate homemade rockets, which travel 70 kilometers at speeds of 1 kilometer per second or so, and carry warheads with yields of 10 kilograms or less of TNT. A nuclear-armed ICBM, by comparison, would travel 10 to 13,000 kilometers at speeds of 7 kilometers a second and carry a warhead with an explosive power 1,000,000 times greater. It's a completely different problem. The Iron Dome interceptors have a range of 4 to 70 kilometers. Even so, with their much more easy target, it's now claimed they're able to disable 80 to 90% of the homemade rockets they engaged, or about 40 to 45% of the rockets launched against the area the system is defending. The difference there is that the system cannot possibly defend against every incoming rocket. So it makes a decision about which ones to try to intercept and which to let alone to fall on Israel. I just emphasize clearly the Iron Dome would fail catastrophically against an attack by nuclear-armed ICBMs. So its capabilities, even though limited, have been useful, but they really have no bearing whatsoever on the problem of defending against nuclear-armed ICBMs. What about defenses against more capable missiles? Well, during Iran's ballistic missile retaliations against Israel last year, April and October, and also this past month, the combined missile defense systems of Israel and the United States were able to intercept about 70 to 80% of the incoming medium-range missiles, expending an enormous number of interceptors in the process. This was labeled a success, and it definitely did prevent some death and destruction. But if these missiles had been aimed at cities instead of air bases earlier in April, October, if even one of them had been carrying a nuclear weapon, reached its target and exploded, it would have been a catastrophe beyond imagining. In April and October, and now this month, the U.S. has helped protect Israel by using its THAAD and SM-3 missiles. Last week, the U.S. moved 5 guided missile destroyers to the eastern Mediterranean to be able to use their SM-3 missiles, and they've been firing them at a very high rate. These are extremely expensive missiles, up to $30 million each, and the reservoir of remaining missiles is decreasing rapidly. Let me now turn to one of the possibilities that's been mentioned for intercepting ICBMs, boost phase intercept, that is, while the ICBM is in powered flight. It's a very challenging problem from a physics technical point of view, even for a very small country like North Korea, not to mention some large country like Russia or China. It is very, very challenging. The simplest but most important challenge is called the reach versus time challenge. ICBM boost phases are short, 4 minutes to maybe 5 for liquid propellant missiles, 3 minutes for solid propellant missiles. Everything has to happen within that very short time. The intercept points for ICBMs from North Korea are more than 500 kilometers from the potential interceptor basing locations. So to get there in that time, the interceptors have to be fast. The defense has little time to decide whether to fire, and interceptors have little time to reach the ICBM, only 100 or at most 200 seconds. This difficulty is shown in the panel on the left for North Korea, where I've shown launch site with the trajectory headed in blue north goes to Boston. The other orange trajectory ground track goes to Los Angeles. So they more or less span the range of directions to targets in the continental United States. The circles, the outermost circles, show in each case the area within kinematically an interceptor would have to be based if it had a 5 kilometer per second speed at burnout. And that's a very high speed, higher than almost all interceptors. You can see that even for such a high speed interceptor, that for the solid propellant ICBM is shown here, there is no area that is a place that is safe for the interceptors to be based. There are many other challenges that must be met for a boost-based intercept system to be successful. You have to hit the final stage, which may be maneuvering erratically or deliberately. You have to defeat countermeasures, such as programmed evasion and so forth. But if a boost phase system cannot meet the reach versus time challenge successfully, all other issues are irrelevant. The defense will fail. So one way that people have talked about getting around this is to go to space. Boost phase intercept using interceptors based in orbit. But there's a complication because the space-based interceptor moves rapidly around its orbit and the Earth rotates under its orbit. A given interceptor will usually not be in the right place to allow it to reach an ICBM that's being launched. This is the so-called absentee problem. This problem means that a constellation of many, many interceptors is needed to ensure that at least one is in the right position to even attempt an intercept. As examples, to defend against the salvo launch of 4 slow liquid propellant ICBMs launched from North Korea against only the mid and lower latitude U.S. states would require at least 1,600 orbiting interceptors. If the system is designed to fire interceptors automatically without verifying the threat, and there's only one interceptor to intercept each ICBM. If the system is supposed to defend the northern states of the 48 and Alaska, many more interceptors would be required. If you have to assign at least 2 interceptors to each to each missile, then that doubles the number. To counter a salvo launch of 10 solid propellant ICBMs and prevent spoofing of the defense would require about 40,000 orbiting interceptors just to defend the continental United States, not including Alaska. And this figure on the right gives you some impression, an artist's impression of what 1,600 space-based interceptors would look like. So how much would this cost? Well, the Congressional Budget Office in May of this year released a response to a congressional question. It said that the decreases in launch costs since 2012, which we're all aware of, from 10,000 per pound to about 1,000 per pound, could reduce the 2012 estimate of the CBO of the 20-year costs of the various constellations. They considered a reduction by 30 to 40%. They concluded that for the 2,000 SBIs that would be needed to counter 1 or 2 liquid propellant ICBMs launched by North Korea, the 20-year cost is now $540 billion, down from the original $830 billion. That's for intercepting 2. That's the absentee problem. In March of this year, the APS released its ballistic missile defense report, the latest report. For the 40,000 SBIs needed to counter a salvo launch of 10 solid propellant ICBMs by North Korea, this construction and initial launch cost could be $1 trillion. In this case, to counter one ICBM, the defense would need to spend about 1,000 times as much as that ICBM costs. This is a significant problem. What about countermeasures? There are many. The launch of the ICBM can be in salvos or staggered. The offense can launch decoy rockets to confuse the defense and deplete the defense's interceptor stock. It can deploy the warheads before the final stage has stopped burning. It can deploy rocket-propelled decoys and jammers during the flight of the ICBM's upper stages. And it could program the ICBM's upper stages to fly evasive maneuvers, possibly in conjunction with releasing decoys to make the intercept much harder. So some people, and this Golden Dome idea has brought this up again, have referred to laser weapons. The advantage of a laser weapon is that light travels fast. So the delay involved in having the interceptor have to go to intercept ICBM is eliminated essentially. But there's been a lot of work on laser weapons ever since the Star Wars program. The APS in 2003, in its report, said that at least a 3 megawatt laser would need to be available if it were as high as 300 kilometers and could dwell on a target ICBM for 5 to 20 seconds to be able to damage or disable it. Well, what are the military lasers now after all these years, decades of work? The U.S. Navy is testing a 60 kilowatt laser on a ship. The U.S. Army is seeking to develop 100 to 300 kilowatt lasers, which it hopes to use against mortars, drones, and aircrafts. We are not close to having any kind of laser weapon that could be of any use for this particular problem. And the prospects are that these are decades, if not more decades away. So we have again the dream of a technological solution to the threat of nuclear-armed long-range ballistic missiles. Just to remind you, over the past 70 years, the U.S. spent more than $400 billion to do this. We are now considering spending hundreds of billions to trillions of dollars more on this effort. This huge and costly effort has never produced a system that could defend the continental United States against nuclear-armed long-range ballistic missiles. And there's no current prospect of deploying such a system in the near future. Personally, I think wishful thinking, ideology, ignorance, and efforts to seek political advantage have repeatedly led to programs that ignore scientific and technical realities. And at the same time, misplaced faith in the current system is dangerous because if it, as Laura will describe, is not effective in most cases, certainly in a battle situation, the idea that it works impedes more realistic and effective efforts to improve our security. So I'll be happy to take a few questions now focused on what I've been talking about.
So please use the Q&A function in the Zoom if you have questions for Professor Fred Lamb, specifically about his remarks right now. And so we have one question, Fred, that is from James Wagner that asks that even if the Golden Dome system worked, weren't there tests like the Starfish Prime test that showed that radiation in low Earth orbit falls back to Earth? And there's also a related question about why are the Russians, the United States, and China all pursuing missile defense programs if they are so technically challenging?
Yes. So I did not have time to talk about all the countermeasures, but clearly one way is to destroy the system. And a nuclear explosion in low Earth orbit or the upper atmosphere would destroy many, many satellites. And that's something that's to be very concerned about, not only because of the missile defense system, but any situation which invites destruction of satellites and other objects in near Earth orbit has the prospect of making that completely unusable by humankind for decades or centuries. So it's a very serious problem. And it would be a problem for the defense, but it would be a problem for us as humans even more. So, as far as why do people pursue these defensive systems, it's part of the way that they analyze the situation. They make the worst case analysis for how the defense would affect their offensive weapons. And then they do decide maybe they'd better spend some effort on this. However, the ways in which they've typically responded, especially Russia and China, is not to try to build defensive systems. Neither of them has. China has a very negligible effort there. Russia has a defensive system, but everyone recognizes that it would be ineffective. Instead, they can build more offensive missiles much more cheaply and much more readily, as I've explained. And they can also build other kinds of offensive weapons, things like submarines, things like um, hypersonic boost glide vehicles, and so on, that defeat the defense. So I do not see a really tremendous enthusiasm by other countries to pursue this kind of attempt.
Thank you, Fred. We have other questions in the chat, but we're going to save them for the general discussion at the end because some of them overlap with presentations that will be made by Laura and by Igor. So if I can I hand the webinar over now to Laura Grego, Senior Scientist at the Union of Concerned Scientists, to make her presentation. Laura, please.
Hello. There we go.
We can hear you fine and see your screen, Laura. Thank you.
Wonderful. Thanks. So as mentioned in your remarks and in Fred's talk, the Golden Dome Executive Order include tasks the Defense Department of the United States to defend against ballistic missiles from peer, near peer, and rogue adversaries. Currently, the only fielded homeland missile defense system designed to protect against ballistic missiles is a ground-based mid-course defense system, which includes 44 ground-based interceptors, a ground and space-based network of sensors, and a command and control system. I will focus on that program in these remarks, and I can also take questions further. We have a short time, so I'll move through it fairly quickly. But since the system is now around 25 years old, I thought it was worth taking a quick look at on sort of the evolving goals that Homeland Missile Defense has been tasked with. Congress has, since 1999, had its stated policy for U.S. missile defense for the homeland. And since 1999, it's been a variation around defending against a limited ballistic missile attack, whether that's accidental, unauthorized, or deliberate, but not to counter peer or near peer strategic arsenals, meaning not to defend against Russian and Chinese strategic ICBMs with this system, recognizing that it would be technically almost unachievable, economically very expensive, and strategically unwise. Each administration almost always tasks the Pentagon to create a missile defense review. And it's been fairly consistent over this time. The defenses have been sized to defend the continental US against limited offensive missile threats posed by states such as North Korea. In 2022, I my reading of this is that it was, I would say, additional missions, but essentially recognizing the difficulty of creating a robust defense. So missile defense was described as reassuring for allies, denying the adversary the ability to execute a small coercive strike, complicating adversary decision-making, mitigating damage, but not necessarily robust defense against these missiles. This was upended earlier this year with the Golden Dome executive order, which really did challenge that logic. And as mentioned, it is an enormous task of defending against all types of missiles, but specifically including peer and near peer arsenals, which is a very different technical and strategic mission. You've seen this image before in Fred's talk. I'm just going to draw your attention to that central section because that's what we'll be talking about for the next few minutes. The ground-based mid-course defense system, which is meant to destroy the after boost phase, after the burnout of the launching ICBMs. Once the final engine has stopped burning, it will release one or more warheads. Any other objects that have been discarded or deployed by the missile, such as deployment modules, insulation, other parts of the booster, and deliberate countermeasures, they move along with the ballistic trajectories in space. Because of the lack of atmospheric drag, their masses will not distinguish them. So even light decoys will move in the same way that heavy warheads would. This mid-course defense presents both advantages and special challenges for the defense. The advantage, of course, as you can see, is that the phase lasts 20 or 30 minutes for ICBM trajectories from North Korea to the continental US, and somewhat longer for launch facilities in Russia or China. That potentially permits multiple intercept attempts. But that long coast through outer space, of course, provides a real challenge with distinguishing decoys from the real target. That's because the warhead is only about 1 meter in length and can appear to radar and infrared sensors as similar to the final stage and other objects that have been discarded and intentional countermeasures. This is the central challenge of mid-course missile defense, as yet unsolved. To be successful, that mid-course intercept system has to adequately address the discrimination problem, identifying the nuclear warheads in the presence of other objects. Again, these could include the rocket's final stage, but possibly deliberately broken into pieces, and other intentional penetration aids such as radar interfering chaff or decoys, about which the defense is unlikely to have detailed prior information. Decoys such as aluminized mylar balloons, which are in this illustration, those pink and gray balloons, can be built to effectively mimic the radar, infrared, and visible signatures of the warhead using weights and heating devices, cooling devices. Many such objects could be included because they're fairly lightweight, and so they don't occupy so much of the mass of the launcher. And if you can't figure out which is the true threatening object, you'll have to engage all of them, potentially depleting the inventory of interceptors. And I think Igor will talk a bit more about this in his talk. Instead of building lookalike decoys, the adversary could disperse objects with a range of radar cross-sections, apparent temperatures, and flight characteristics, which is called an anti-simulation strategy, which makes it, rather than trying to mimic the warhead, make a range of objects that and potentially enclose the warhead within a balloon itself. These techniques have been well known for decades. Intelligence estimates have said that basically any state that could produce intercontinental range ballistic missiles would have the technology to produce such countermeasures. Rather than confusing the defensive system's sensors, an adversary could instead attack or interfere with those sensors. Long-range mid-course interceptive warheads depends on a geographically spread chain of sensors, primarily radars, for tracking and discrimination. Continuous observation of the threat cloud, which is this picture over here, is important to prevent tracking errors from growing and allows you to try to pick out the real target. An adversary could try to disable key sensors, especially forward-based radars that are within the reach of short and intermediate range missiles. The adversary could also confound the sensors without attacking them directly by creating radar and infrared blackout effects with high-altitude nuclear detonations. Those incoming warheads could be designed to detonate before an interceptor reaches them using a long-established technology of proximity fuses, or the warheads could detonate either intentionally or accidentally when struck by an interceptor. A nuclear detonation at an altitude of hundreds of kilometers would create a large volume of ionized gas that would attenuate the radar signals passing through it, which makes it more difficult to track and especially difficult to discriminate because there'll be lots of fluctuations in the signal that have nothing to do with the actual objects. That ionized gas would also generate high and spatially variable infrared backgrounds over similarly large areas, making it difficult for the infrared homing sensors of the kill vehicles. Any credible mid-course defense would need to demonstrate an ability to deal effectively with such countermeasures. In 2001, so back to the system that the specific system, 2001, George W. Bush announced that the U.S. would withdraw and end the anti-ballistic missile treaty that had been in place for 30 years. Soon after, the Bush administration announced it would rapidly field the ground-based mid-course defense system with the goal of having an initial operational capability by late 2004. Sounds fairly familiar. The Golden Dome system in the recent announcement said that the U.S. would field an initial capability in 3.5 years before the end of the president's term. This is a sequence of events, a lot going on in this picture, but basically this is how the system as it exists works. About a minute after a threat missile launches, infrared detectors would detect it. Forward-based radars would catch a sight of it, start to communicate with command and control. And as the objects pass through increasing tracking radars, intercept point would be calculated, and the initial attempt to discriminate which is a real threat would begin. A choice is made to launch an interceptor. So the GMD interceptors are mainly in Alaska, with 4 in Vandenberg Air Force Base, California, but they launch, they look very much like an ICBM themselves, and each of them would release a single kill vehicle. Kill vehicle is something around the size of a small refrigerator or a file cabinet, and essentially is a sensor with some rocket sort of small rocket engines to direct its flight, but it's being sent to an intercept point, and it will maneuver itself until it can home in on and ram into its intended target, destroying it with the force of impact. So that's the system as built. So back to the matter at hand, I'm going back over the history of the GMD system because I think it has important insights for what's happening with Golden Dome. When the initial research and development of the ground-based interceptor missiles drew on technology from the previous decade. And under this accelerated timescale for fielding, the Bush administration cut some corners in terms of oversight. It removed missile defense from the normal sort of fly before you buy oversight, accountability, and financial transparency procedures that Congress and the Pentagon had learned through years of experience are necessary to build a system successfully. And this graph on the right is sort of an illustration of that. So you'll see along the bottom, it's a timeline, and along the top is the number of interceptors emplaced. The blue and the yellow are just describing 2 different flavors of interceptor, but basically, and then you'll see the testing program with key points in this graph. And what I'd like you to notice from this is that these interceptors were put in the ground and fielded in each case before any successful test, even a single successful test of the interceptor had been completed, indicating that the system was being fielded on a political timescale rather than a technical readiness timescale. That is widely understood now to have been the source of a key source of the problems of the current system, which doesn't work very well. It allowed the fielding of poorly tested equipment. It shortened it minimized the types of tests the system had to go under in order to be procured. I would say, according to the Undersecretary of Defense for Procurement and Engineering, the quote was, we saw a lot of bad engineering and because there was a rush to get something out. So this approach produced failures and not cheaply. this again is the test record of the system, and you'll see red is failures and green is test successes. These are intercept tests when the system is meant to actually destroy a target. And this is important because to incorporate the system, to use it, to decide how to use it under conditions that could include a real attack, you have to know a lot about the system. You can't sort of wing it. You really do need to know. The system, despite it's a fairly slow pace of tests, the tests have been mainly organized for success. They haven't been particularly challenging tests. On the left, you'll see some of the weaknesses in the test program. They haven't been tested against missiles that are the correct range. The lighting has been the same, favorable lighting for each test, no tests of salvos of simulated warheads. It appears to have never included complex countermeasures of the types I described above, and it's a slow pace of tests. So I'd argue from this, there's a real weakness in understanding the capabilities of the system, which is not only important for the ability to develop a working system, it's also critical for making political decisions. If a strategic missile defense is expected to be highly effective, because it has to work against an existential threat, and it must work the first time it is used, you really do need to know very much about how the system works. So given that test program, the current assessment by the independent test authority in the Pentagon, which is called the Director of Operational Test and Evaluation, assessed in 2024 that when using everything going right with the sensors and command and control, the system has demonstrated it has some capability to defend against a small number of missile threats using simple countermeasures. Sort of digging into what that means, you can imagine this doesn't give you an effectiveness. It doesn't give you any real particular sense of how well it does that. There are some improvements planned, including the current coming online of a long-range discrimination radar, which is meant to address some of these discrimination challenges, which I didn't describe here. And they will be trying to fix some of the quality control and design flaws of the current generation of interceptors by building a new interceptor, which is meant to come online beginning in 2028. But when looking at the system as a whole, which the American Physical Society panel on public affairs did in its preparation of its report that was released earlier this year, the conclusion was due to its fragility to countermeasures and the difficulty in expanding it readily or cost effectively, the system can't be expected to provide a robust or reliable capability against a small number of North Korean missiles. Here's a reason that's important. Understanding how it works and understanding these, it's sort of funny, but it's not meant to be funny. The political system really wants the system to work, it wants to tell the population it believes it works. If you compared these quotes about how well the system works against the test program, you'll see that before there was evidence that the system worked well, there were political claims that it did. It's not just wasted resources, that has real consequences. If you think the system works better than it does, you might pursue more aggressive policies. It might increase the risk of nuclear exchange, and an over-optimistic view of the capabilities of missile defense could diminish the incentives to vigorously pursue other potentially more effective approaches to the critical problem of nuclear and ballistic missiles. So in conclusion, just very briefly, despite significant investment of resources and decades of effort, the GMD system hasn't been shown to be reliably effective. It is still no demonstrated solution to the problem of countermeasures. Developing the GMD system on a political timeline rather than the basis of technical readiness led to costly failures. That so certainly something that we might expect will happen with the Golden Dome. Misunderstanding and overestimating the capabilities of missile defense can be very dangerous. I didn't talk very much about this, but I'd be happy to in the Q&A to talk about the adversary getting an answer and the problem of the pursuit of offensive capabilities to overwhelm, evade, and directly attack missile defenses, leaving the world with more nuclear armed missiles, and as Fred ably mentioned, a technical dream of defending against them that doesn't work. That'll help. Very concerned about missed opportunities for a more peaceful future. So thanks. I'm happy to take your questions now, maybe a couple, though we're short on time, or at the end.
So thank you, Laura. Again, if there are specific questions for Laura, so there's one from Ryan Nesselrod asking, do we know what simulated countermeasures were actually used in the past GMD tests?
Yeah, we have some idea of that. There was a lot more information at the beginning of the development of the project. There was more public visibility into that. That was pulled into the classified world, a few years in. So there's less public view, but we have some sense about what those were. There is some information released post-test, and the director of developmental test and evaluation also produces a report that looks at the test program and evaluates it on operational sort of realness and has a checklist. So we have some sense of the limits of that. I can send a paper in the resources after the webinar that does a pretty in-depth look at what we know about those.
Thank you, Laura. So let's now move on to our third and final presenter for today's webinar, and it's Dr. Igor Moric from the Princeton Program on Science and Global Security. Igor, please.
Thank you, Zia, and thanks to the coalition for this opportunity to speak. I hope you see my slide.
Yeah, we can see your slides.
Okay. So according to the executive order on the Iron Dome for America, which was since renamed the Golden Dome, and some past statements from President Trump, the dome is supposed to shield every city in the United States against any aerial threat, including ballistic, hypersonic, and cruise missiles, no matter from where they are launched and by who. And as Laura said, this means U.S. ballistic missile defense is moving away from defending against rogue states and accidental launches to defense of its citizens and infrastructure against any foreign attack, including against peer and near-peer adversaries. And as Zia mentioned, to accomplish this, the order asks for plans to develop space-based interceptors, which are capable of boost phase defense, as well as being able to defeat missiles before they launch. This, of course, is not the first attempt to build a nationwide shield against all external threats. When President Reagan announced his Strategic Defense Initiative in the 80s, an attempt to build an ambitious missile defense system of systems equivalent to the Golden Dome, he wanted to build an invincible shield that can protect against nuclear war like a roof that protects a family from rain, eliminating the threat of nuclear attack. More recently, President Trump said there is no greater menace than the threat of nuclear weapons. He warned about the destructive capability of nuclear weapons and the need to reduce massive nuclear arsenals and massive budgets spent on them. And I think we can all agree with this. Unfortunately, while it's easy to like the idea of the Golden Dome, it will accomplish the opposite of these goals. It will damage US security by causing an expansion of already bloated nuclear arsenals, increasing the risk of nuclear escalation without providing any meaningful protection against nuclear war. The imagined Golden Dome would consist of a network of ship, land, and space-based interceptors, aided by ground-based radars and space-based inference sensors to detect launches, track attacking missiles, and help guide the interceptors. As Laura and Fred have shown, there are many difficulties with mid-course defense, which the existing US missile defense system have been focusing on. It is not possible to do boost phase defense with ship or land-based interceptors because it's not possible to place them close enough to launching sites in Russia and China. So the Golden Dome has this one magic ingredient that may be able to solve this problem and allow destroying missiles as soon as they launch. And these are, of course, the space-based interceptors, which could be placed in orbit close enough to launching sites to destroy missiles immediately before they have the chance to exit the atmosphere and deploy their warheads, or even before they are launched. Now, even if the United States had the technology and the manufacturing capability to produce and launch tens of thousands of space-based interceptors required to stop Russian or Chinese attack, and they do not. And even if Russia and China would not mind having tens of thousands of weapons overflying and covering every part of their territory, which of course they would mind and try to shoot down, this would be incredibly costly. In addition, a single layer of interceptors would not be enough because the attacker could destroy the missiles with relatively cheap missiles or other satellites, punching a hole through which their long-range missiles could pass. And China and Russia already have these capabilities. They could also pollute the orbit with debris or detonate a nuclear explosion in orbit, making the Golden Dome sensors blind, and then attack. This means the United States would have to deploy multiple layers of interceptors in different orbits, multiplying the overall cost of the system and making the whole concept difficult to imagine, both by cost and the technological complexity to make such a large number of systems interact with each other and with its distributed sensors. Understood as a bullet hitting a bullet, there is often a widespread misunderstanding how missile defense works and what it can and cannot do. Since the inception of missile defense programs in the United States, encouraged by the optimism of the military contractors, interest in developing systems to defend the homeland against all missile attacks periodically emerges, with the enthusiasm regularly diminishing once the decision makers realize the technological limitations of missile defense, the high cost of developing them, and the strategic implications of fielding them. Now, while the idea of the Golden Dome, a protective shield against all external threats, is appealing to both decision makers and the public, it is technologically and conceptually broken. And this has not changed compared to the 80s. So arguments made by Betta and Garvin in 1985 that the offense can be overwhelmed with relatively cheaper warheads or outfoxed with decoys, and that you can destroy space interceptors with relatively cheaper missiles are equally valid today as they were then. Responding to President Trump's executive order, SpaceX and Palantir and Anduril are offering launch and data management on a subscription model. Lockheed Martin has called for a Manhattan Project scale effort to deliver the Golden Dome, while L3Harris, which has already opened a manufacturing site specifically aimed to support the Golden Dome effort, wants to accelerate the US response to this catastrophic threat. Supporting both legacy and emerging defense contractors, this May, the Golden Dome Caucus was formed in the US Senate in order to, and these are the quotes, working together make a generational leap forward in missile defense, reimagine how we acquire things to support our warfighter, and to support the project with the scope of the Apollo program. However, the amount of money so far spent on missile defense is already many times more than the cost of the Manhattan Project in inflation-adjusted dollars, a few times more than landing the first man on the moon, and double what's estimated to land humans on Mars. The United States has spent about $200 billion on missile defense since 2002, and a total of about $500 to $700 billion since the 60s. To build the Golden Dome, President Trump set aside $25 billion in next year's defense budget, with the total cost estimated at $175 billion by the end of this term. And this may seem like a large amount of money, and it is a lot of money, but it doesn't actually buy much missile defense. For example, according to the 2021 analysis by the Congressional Budget Office, the 2020-29 estimated cost for missile defense development were already estimated about $200 billion. And this is focusing only on existing land and ship systems without the magical, costly space-based component and before Trump's executive order. So realistically, $175 billion will not build tens of thousands of space-based interceptors required to protect against Russian or Chinese attack. It may build a prototype and we may see a demonstrator mission, but not more than that likely. A recent CBO review also estimated that the space element alone could reach as much as $542 billion to deploy and operate in the next 20 years. This is to defend against a limited North Korean strike against one or two missiles, a country much smaller than Russia or China, with a much smaller, less advanced arsenal. It would realistically cost trillions to defend against Russia or China, with none of the issues that Laura or Fred or I mentioned. And this all implies Russia or China would just watch and do nothing to counter such a massive undertaking. And there is plenty they can do. They can develop novel countermeasures. They can build more weapons. offensive weapons. They can deploy their own constellation of weapons. They can deploy nuclear weapons in orbit, something Russia may already be attempting to do, as we have seen in the news. So because of all these reasons, it is unrealistic to expect that the United States will deploy the space-based component of missile defense in the next 3 years. More likely, most of this money will go to expanding existing land-based and ship-based interceptor systems, as well as the major effort already underway to build up a new generation of land radars and space-based sensors. Therefore, focusing on land and ship-based interceptors, so Aegis and NGI, which Fred talked about, calculations I performed with Timur Kadyshev show that if you compare the cost of Russian or Chinese ballistic missiles equipped with warheads to the cost of US interceptors placed in an optimal two-layer defense, and if you ignore the past development and projected future cost, so if you assume that the technology is already there, it works, the United States will need to spend about $8 to defend itself for every dollar Russia or China spend to attack. This is a very optimistic scenario where the system can stop 90% of all incoming warheads and perfectly reject all countermeasures. In a more realistic scenario with proven interceptor kill effectiveness of about 50%, and if the US cannot reject all countermeasures, they need to spend about $70 for each dollar Russia or China spend to attack. This means that even ignoring the space systems, the cost exchange dynamics heavily favors the attacker. Now, it's often said that nationwide missile defense, as imagined in the Golden Dome, is too expensive. But as President Trump said, and this is a quote, some funding is tough and some is easy. When you say we will save everyone's lives in a crazy world, it seems to be very easy to get. So yes, if missile defense can forever end the threat of the missile threat, as also a quote from Trump, why not? The government spends money on worse things. Similarly, Reagan asked and answered, but isn't it worth every investment necessary to free the world from the threat of nuclear war? We know it is. And that's the problem with such statements about the cost of missile defense. It's sort of misleading. It wrongly implies all it takes to build a shield against war is some more money. And whether it's millions, billions, or trillions, this is not very tangible to most people. In fact, that's not the issue. Missile defense is so much more expensive compared to attack that attempts to establish it incentivize attackers to outspend the defender by acquiring offensive weapons at a much lower relative cost. As a reminder, analysis shows the United States needs to spend 70 times more than Russia or China on average. And Russia and China know this. Russia is modernizing its arsenal. China is expanding it. They're also building weapons aimed to evade missile defense, such as hypersonic vehicles. Russia also claims to be developing Poseidon, which is an autonomous, long-range, nuclear-powered underwater vehicle capable of delivering conventional or nuclear warheads to coastal cities. And no amount of space-based lasers can stop that. The Golden Dome cannot stop such weapons. In conclusion, missile defense is not a solution for nuclear war. It is bad for deterrence, and its cost exchange invites adversaries to build up. In a sense, within an arms race dynamics, it subsidizes the other side to build more without providing protection and without deterring an attack. Golden Dome will end in failure, but not before hundreds of billions are spent and the world becomes less safe because US adversaries end up with even more nuclear weapons and more ways to deliver them to the United States. And any attempts to build the Golden Dome ensure such a future. Thank you.
Thank you, Igor. And can I ask Laura and Fred, please, to rejoin the webinar, and we'll move now to some of the questions that have been posed to our panel today. And so let me begin, if I can, by asking that Victoria Sampson asked that one of the arguments that the supporters use for space-based interceptors, and this also is for Fred, is that even if you aren't successful with the space-based interceptor in the first go-round, and as Igor mentioned, there are layers of space-based interceptors envisaged, there are these follow-up defense, missile defense systems all the way to terminal defense. Could you talk about the technical issues that are related to that set of issues?
There's a lot that one could go into here, but I will just emphasize one point, that it's the assumption behind this kind of question, which is natural and question that many people pose, is that it's going to be easier for the mid-course system to actually clean up after a boost phase intercept attempt. And the 2003 APS study considered this and came to the conclusion that it was far from clear that that was the case, because the debris from the intercept attempts or intercepts by the SBI system can make it much more difficult for the mid-course system to actually pick out the warhead. And there's lots of other things that come in with that. So it's not as quite as obvious as it sometimes seems. So I'll leave that there. Perhaps Laura has some more to add.
Well, I think space-based and boost phase missile defense looks attractive from the point of view of mid-course defense, because mid-course defense is so hard, and you have there's no way to proceed if you can't discriminate, and we have not demonstrated the ability to do that. Not even just engineering, but solving the right physical measurables to make that a tractable problem. So then and then you try to do boost phase and you're faced with this very intractable absentee ratio problem. So I think that's always the challenge, is that the grass looks greener. So of course, combining systems, they'll have different failure modes and flaws. And so, I would say conceptually, the question makes some sense. As Igor demonstrated, the costs just multiply. And for each of these systems, there's a way around them. There's the offense continues to have effective, cost-effective solutions to each of these systems. So I think you can't escape the main logic of the system, is that the adversary will cause you to outspend, and almost certainly you're not going to be able to achieve your goal because of these straightforward countermeasures.
Igor, do you want to comment on the layers and layers of space-based interceptors and the terminal defense, dealing with what you can't
Very
get the first
difficult
time
to
around?
know this at this point in time, I think, because we haven't actually seen any concrete proposal how this would look. So I think what Fred and Laura said, that there is not much more to be said at this point.
Okay, so we have a second question, since we have Canadian colleagues. Canada has been interested in joining the Golden Dome project. And so the question is asked by one of the members of our audience, that how and in what ways could Golden Dome defend Canada? Would that involve having more space-based interceptors or other kinds of architecture that would then add to the complexity, cost, and problems of Golden Dome? So does anybody want to take that on? It does connect to the question of defending allies that was mentioned.
Well, perhaps I'll just, there are, again, a lot of things one could say, but I think that the thing about space-based interceptors is that it's not the target of the missile. That's what the interceptor is trying to seek out. It's the launch vehicle itself. So there is, however, an interplay here. That is, that if the target is closer physically to the launch site, then the missile doesn't have to burn as long. And that's a huge problem for space-based intercept. So that's why I talked about, if you wanted to just defend Kansas and Texas, then you have this many thousands. If you wanted to also defend Minnesota, it gets much bigger, just because Minnesota is closer to North Korea. So Canada is closer to some of the launch sites. And so the missiles headed to Canada, the offensive missiles don't have to burn as long, and then that's a huge problem. So that's kind of how it interacts.
Thank you. So if Laura or Igor, if either of you want to add to that, or we can move on to the next question. And we have a question about do the panelists think that there are these space-based systems, could they provide defense against multiple attacks, or is this, once the space-based interceptor has been used, then it's used up and has to be replaced?
Okay, so I'll answer that fundamentally, once it's used, it's gone. The chances of restoring the constellation by launching new interceptors on any relevant timescale, even if they were available and that could be done, it's not possible. But another thing is that if you have only, say, 1 or 2 interceptors that have been used up, then if you have these 40,000, some more interceptors will orbit into that same space within typically 200 seconds or so. So in that sense, the constellation can restore its defense capabilities in that way, but that's still the system itself is being degraded.
If I can add something. So
Please.
there was discussion in the 80s about the space-based interceptor hosting multiple missiles and kill vehicles. But the issue with that is that then it changes the cost exchange dynamics, because the offensive missile, so for example, something equivalent to the DF-26 Chinese one, which will be able to shoot down interceptor, is about $5 to $10 million cost. And if you have multiple missiles hosted on one satellite, then you are giving an advantage to the attacker, actually. So that was, I think, a paper by Garvin in the late 80s, who discussed this. So having multiple interceptor missiles on a single satellite.
We have a question from Ambassador Paul Meyer from Canada that said, could someone comment on the detrimental impact of Golden Dome on the future of possible arms reduction talks, given the dynamics that you've identified? So Laura, do you want to start with that?
Sure. That's a great question. So we know very well, and I think Paul does, intimately connected to this, that that offenses and defenses are tightly interwound strategically, and Russia has consistently pushed for missile defenses to be included in arms control talks, and has stated repeatedly that New START is the last time we'd get through nuclear reductions without some kind of addressing of missile defenses. So that's always been part of that conversation. So in terms of arms reductions, I think it also has, of course, the effect of limiting, of incentivizing, as we said, our offensive increases, which also interfere with these strategic reductions, because of course adversaries are very concerned about the erosion of their strategic deterrence and are taking measures. Igor mentioned some of them, so did Fred. Of course, the inclusion of new types of systems, new types of delivery systems, whether it's a nuclear-powered, nuclear-armed cruise missile or an underwater drone, or a move to MIRV missiles, meaning putting multiple independently targetable reentry vehicles on missiles, so increasing the numbers that will need to be dealt with. So it increases the complexity and the numbers of the strategic situation, making arms reductions very much more challenging. So also, and I know this is close to your thoughts, it can, the strategic missile defenses, especially the SBI, can impede efforts to create better arms control situations in space, because those are, while they're described as defensive weapons, they certainly can be used as offensive weapons. So the presence of missile defenses can also impede arms control in space.
I can also add something to that.
Please, Igor, go ahead.
So I think it's also connected to a question I saw before. If Russia and China know all these things, why are they building up? And it's important to also say, I think, that all sides plan for worst case scenarios. So as the US plans, so does Russia and China, for the possibility that this may actually work at some point. And even if it doesn't work, it might have some limited capability. So if you have 10 offensive weapons and the US can stop 9, that means 1 can leak, but you have 100 and you can stop 90, it means 10 can leak, and so on. So it naturally incentivizes the buildup of weapons, which of course is not good for stopping nuclear arms racing. And of course, there is also a more simple answer, that none of these things have much sense or logic, and that there are no adults in the room, and people do what they did before. They go to their job and they do what the person before them did. So they will naturally respond to what the US is doing and building up a missile defense by building up their own capabilities.
Could I just add something that building on what Laura and Igor said, and that is we have to step back and realize that the net outcome of this competition is likely to be that there would be more nuclear weapons exploding on the United States if we drive the adversary to build more nuclear weapons. Because just as Igor said, they would be making worst case analyses, but actually the way the system works, defensive system is probably not going to work very well. So now we have 10 times more nuclear weapons coming at us. So it doesn't make sense.
So thank you. And we have a question from William Faulkner that speaks to some of this, that's addressed to Laura, but perhaps Fred and Igor also. And so the implication of William's question is that despite everything that we've said about missile defense, and you've all mentioned that it has a long history of making promises and not actually being able to deliver for all the reasons that you've identified, and yet missile defense continues to be attractive to policymakers. And so this is the third, fourth generation, at least, of efforts at developing this in the 60s, in the 80s, in the 2000s, and now in the 2020s. So it seems every 20 years, there is a new missile defense system that is kind of brought up. And this time it will solve the problems that were not being able to be solved before. And so William asks, so is there a different narrative around missile defense this time in comparison to previous times? Is it always the same narrative that drives the argument? And if our previous narratives against missile defense keep failing to prevent it being reborn, then or resurrected, then do we need a different set of arguments that will actually, end it permanently for the reasons that you mentioned? I mean, are we making the right arguments given the cases that are actually being made? So we'll start with Laura, then Fred, then Igor.
Well, this is a great question, and interesting. I'm gonna give a slight pushback at the beginning, in that while I don't think it's been wonderfully successful at always dispelling the myth of missile defense, it certainly could be a lot worse. I think the system has taken a look at space-based missile defenses periodically and recognized the infeasibility, the technical infeasibility, economic challenges, and has rejected it. That, I think, is a success of the message of how it works and it doesn't. And I think sort of taking a look at the slide went by pretty quickly, but it was describing sort of the changing goals for missile defense, I think, have became more brought in line with reality. Rather than provide an impenetrable shield, it became more like make the decision making more complicated for your adversary. So sometimes I think the messages start to sink in. So I think missile defense will always be attractive because of the intolerable vulnerability to nuclear weapons. As soon as you recognize that you want to get out of it, it's a nuclear weapons threaten us all. And so in the United States, being a special kind of society, imagines we can technologically get ourselves out of this vulnerability. I think I don't know if this is correct, but I think when I'm in these conversations, I like to turn to much more realistic ways to decrease our vulnerability to nuclear weapons, more robust, more permanent, better ways to mitigate the risk in our systems. Absolutely has to do with getting rid of risky technologies and policies and strategies, and eventually bringing nuclear weapons under control and dismantling them, and that's our permanent way forward. And that you have to keep your eye on the ball and not be distracted by the shiny missile defense, that it's not going to solve that problem for you. And that's, I don't know if that's the most effective messaging. I'd be very interested to hear everyone's ideas about what might make more success. But I would say the technical arguments have sometimes maybe not improved the situation, but helped it not become worse.
Fred, Igor, do you want to add?
Yeah. So I'll just add one. I think Laura's answer was really superb. I think there's another aspect too that we need to pay attention to, which is that there are advantages to advocating for building a missile defense that are political and financial and many other things that don't really connect with the technical analysis or whether it's really going to work properly and so on. A person can promise to the public that they will become safe. That's really, really appealing. And the technical arguments are on a different level. And the same thing with money. There's, as you know, we've talked about, and Igor and I have emphasized, there's potentially trillions of dollars available here for the defense industry. So, and they are the people who can make the technical arguments for it. They may not stand up, but they have tremendous resources behind them. So we have to be realistic too about the way in which society works and human beings work. It's very uncomfortable, as Laura said, to be faced with this, but I think we've done pretty well, all told. I hope we can do better.
If I can add also, it sounds like a great idea, and I don't think it will ever completely disappear, but it's presented frame as an alternative to nuclear competition as the only way to eliminate the threat of nuclear war. And we have to offer a different alternative to that, and that's to eliminate nuclear weapons. So there is another option beyond just missile defense to eliminate this threat.
Thank you. It's interesting that, the way that you framed this, it reminds me that people have often forgotten that along with proposing Star Wars, Reagan also agreed to ban nuclear weapons, and specifically for a ban on nuclear missiles. So people are adopting one part of the Reagan approach, but not the other part of dealing with this question. So we have two questions.
I could just say, just a final comment on that. I think you can argue that the only effort that really substantially reduced the threat of nuclear weapons was the arms control agreements between Gorbachev and Reagan that reduced the number of nuclear weapons from 70,000 to 10, 15,000. And that's a huge difference. And it was done that way.
We have a few minutes left, and let me try and get in a couple more questions. So there's one question that's interesting from Vivian Zhang, who's asking, what potential new capabilities might be developed as part of Golden Dome, which may have applications beyond just the Golden Dome system itself and create new kinds of capabilities? So let's start with that one. Does anybody want to have a go at that? Igor?
I'm still reading the question, but yes, it's absolutely weaponization of space. It's an excuse to put more stuff in orbit, including maneuverable satellites, including more sensors. So even before the Golden Dome, we had this massive push by the Space Development Agency to place hundreds of new satellites, communication satellites, transport satellites, and sensors in orbit. There is an effort to also put maneuverable satellites in orbit, and all this will accelerate these efforts for China, for Russia, for the United States. So even if we don't actually see interceptors in the next few years, we will see this as an excuse to accelerate these efforts, which will remain after the Golden Dome.
Laura, Fred, do you want to answer that?
Yeah, I know this isn't exactly what you're asking, Vivian, which is more the technology. So the more of the technologies, I think the investments are going to be in this complex, incredibly complex command and control system, which would be necessary to realize anything like this. The push to, as Igor said, have more sensors, populate low Earth orbit with sensors in what they call, I think, a space transfer layer, a custody layer, which is a communications. I think a lot of that, the complexity, and of course, when you do things at big scale, you probably innovate, and there are things that spin off. But I think that does presuppose that this project goes in a large sense. And one of my concerns, and this isn't particularly a technical innovation, but and the periodic relooks at space-based missile defense, there's often been an idea floated that we'd make a space-based test bed, which is just to try out a couple of interceptors, see how they work. And I've always been really strongly opposed to that because, and as another question in the queue mentioned, those types of interceptors are almost certainly potent anti-satellite capabilities, because satellites travel in the same part of space with similar speeds to ICBMs. In many ways, a space-based interceptor would be overqualified for the job because they'll have a capability to rapidly maneuver in an endgame, and satellites are quite predictable in where they go. And they might need a different sensor, for example, but what they could also do is reach geosynchronous orbits because they'd be powered enough to do that. So it would be the introduction of a very well-tailored space weapon into space, where I know the norms have been eroding a bit, but there's been a pretty significant restraint about space weaponization, and that would be sort of an unambiguous step in that direction. I think without realizing this huge industrial project, you could still have some real taboo breaking with a system like this. And that's something I would really think we should keep our eye on as a legacy of Golden Dome.
Thank you. So let me ask a quick follow-on question, and then we'll move to one more from our webinar participants. Given the need for technology development still to take place, and what you've said about the failure of the current testing programs and the limitations of the mid-course testing program and so on, and the recent announcement that the Pentagon's Office of Test Evaluation is to be cut back, what do you see as what we should be looking for as signs of failure early on in this, and what can be done with those signs of failure in terms of making the case against the continued progress on Golden Dome? So can someone say about this effort to take away even more of the testing and independent testing and evaluation functions, and what that says about the likelihood of failure, and what we can do with failure in the arguments on this matter?
I've had a lot of airtime, so I'd be happy to pass that to Fred or Igor, if you'd like to answer it.
I'll say a couple of thoughts. I think, unfortunately, because of things like reducing the operational test and evaluation and other things that would naturally occur anyway, it would take quite a long time to have a real case based on what has happened so far that you couldn't do anything better further along. So I think we have to argue about what really the capabilities would be, even if they did do what they think they could do, and what the consequences would be, and try to cut them off at the pass, as it were, rather than, waiting for some kind of test to show failure soon enough to be useful.
Thank you. Igor, do you want to add to that? No? Okay, thank you. So we have a few minutes left, and so we have a question from Stephen Schwartz, who asks, can you address the potential future risks posed by a president of the United States and true believers in his administration and Congress who have faith in Golden Dome and pursues a more aggressive foreign policy with nuclear armed adversaries, on the assumption that, yeah, the United States will actually be able to defeat any attack or counterattack, so that they feel this shield actually does what they need and therefore are empowered to be more belligerent? So what kinds of risks do you think we run, and are there examples or issues that you want to kind of bring to the fore for our audience today?
Well, I'll take a first stab at that. As you know, that was a big theme in my presentation. That is a real concern of mine. If you don't have an operational test and evaluation program, if you don't put the test through the paces, you can believe anything you want about the system if you don't know how well it works. And as demonstrated by not just the quotes that I put on my slide, but there's dozens of such quotes where policymakers, whether misinformed, misunderstand, or just plain lying, think that the system worked 97%, 100% of the time. So you can imagine getting into a conflict with North Korea, for example, or any situation where you might expect, you might think maximum pressure on your adversary will be backstopped by your ability to defend against their threats, and completely misunderstand that case. I think in the case of China, it's also important to think that through. China has historically had a much smaller nuclear arsenal than the United States, and Russia declined to pursue that path to thousands of weapons. That may be changing, but the but they've been long concerned about not just missile defense, but in concert with other technologies the U.S. has been pursuing, including prompt global strike, precision-guided munitions that might put their command and control at risk, the ability to track mobile missiles from space, a real concern that putting all of those things together, the United States might think it had the ability to strike China first without fear of retaliation. And you can imagine any kinds of scenarios where the U.S. might make policy choices that are dangerous under a belief like that. So for me, it's not just wasted money. It's not just poor oversight. It's a real political and strategic question about building missile defenses without really understanding what you're doing. It's not just a folly. It can have real problematic consequences.
Fred, Igor, do you want to add to that?
No, I think for me, Laura summarized it very, very well. I might just say that I have known really well some of the people, the leaders who've said these kinds of things, which are absolutely not true and disprovable. And it's really hard for me to understand, to reconcile their integrity in other ways with saying things like this. But it happens all the time.
I would like just to add that it's difficult to independently confirm effectiveness of these systems. And I would echo the concern that posturing that they work at 100%, as we've seen recently, can have consequences which are serious.
Thank you. So we haven't had time to get through all of our questions, but I do want to kind of wrap up our conversation today. And as you'll see in the chat from our policy and communications manager, you can get a recording of today's webinar and of the slides by the panelists on the Physicists Coalition website, which is physicistcoalition.org. And that's also where you can go to join the coalition, and it's free to join. And when you sign up there, you'll receive notification of upcoming events and activities. And there are also various resources that are available on the Physicists Coalition website on a number of issues. And we will try and make available, along with the recording and the slides from today, some resources on missile defense, the scientific and technical issues of missile defense work that's been done in the past, and resources where colleagues can learn more and use to educate others about the challenges of missile defense and what it means for trying to reduce the threat from nuclear weapons. So with that, let me thank our speakers, Professor Fred Lamb, Dr. Laura Grego, and Dr. Igor Moric, and our wonderful policy and program manager at the Physicists Coalition, Chris Rastanpour, for putting all of this together. And once again, a special thanks to the Union of Concerned Scientists for allowing us to use their resources to host today's webinar. And as all of our panelists have emphasized, the advocates of missile defense have been trying to get this thing to actually do real work in the real world since the 1960s, and have been fought to a standstill, both by the realities of technology and by the determined efforts of scientists, policymakers, and the public to say, hang on a minute, this makes no sense, actually makes things worse, not better. And I think we're now into the next round of this. And so I believe that together we can once again kind of hold the line with regard to the fact that reality has something to say, no matter what ideology or corporate interests may wish the world to be. So thank you all again for your attention, and we look forward to seeing you at a future Physicists Coalition event.